So good afternoon. Good afternoon, everyone.
Afternoon, sir.
Good afternoon, sir.
Good afternoon. Shall we start the class? I think 22 people. I don't know how many will join. So we'll start the class straight away. So last topic is what we stopped here is like compliments. Okay. So we have seen the topic of compliments here. So am I audible and you can see my screen, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So we'll talk about the compliments here. So the compliments are of two kinds here. So one is a radix complement, other one is a diminished radix complement. Okay. So what I can say here is R's complement and R minus one complement. Okay. So if I say that if you have a decimal number, so decimal number radix is 10 here. So we can have two complements for a decimal number. So that is tens complement and nines complement. Okay. And for a binary number, we can have two complements here. So that is R is 2 for binary. So R value is equal to 2 for binary. So we can have 2's complement and 1's complement. Okay. For hexadecimal number, we can have 16's complement and 15's complement. Okay. In a similar way, if it is like R, where R is the radix of any kind of number system. Okay. If it is an octal number system, the radix will be equal to 8 here. So there'll be two complements possible here. So one is radix complement, other one is the diminished radix complement. So radix complement is R and diminished radix complement is R minus 1. Okay. So first we started with 2's complement here. So 2's complement and 1's complement for the binary number system. Okay. So first of all, I have to take R minus 1 complement and add 1 to the R minus 1 complement so that I'll get the R's complement here. Okay. You can see here. So the ones complement of the number, what we get from the ones complement number is, so here ones are changed to zeros and zeros are changed to ones here. Okay, the value of 1 is changed to 0 and 0 is changed to 1 in case of the ones complement. Okay, so the major technique behind this is, so we have to subtract each and every digit, each and every digit of the binary number from 1. Okay, you can see this. Can subtract each and every digit from 1 here so that I'll get the ones complement. So simply what I can do here is, so ones complement is, so changing the values of zeros to ones and ones to zeros. So that is ones complement. Okay. So adding two's complement is nothing but, so adding 1 to the ones complement. Adding 1 to the ones complement. So if I add 1 to the ones complement, I'll get the two's complement here. Okay. So this is ones complement here. So the ones complement of this number. So 10110000 is 010011. So this is ones complement. And if I'm adding 1 to this, I'll get the two's complement. Okay. So if I add 1 to this, I'll get the two's complement. So what I have to add here? So I have to add this to the least significant bit here. Okay. So I'll be adding this 1 to the least significant bit. What I'll get here is, so if I add these two, I'll get the two's complement. Okay, so the two's complement will be like this. The value is 1 1. Generally 1 1 is 2. So 2 binary, so sum is 0, carry is 1. So we'll get a carry here. Okay, so here we get a carry. Okay, so 1 1 is 0 1. So 0 is sum and 1 is the carry here. And for 1 1, it is again 0 and a carry of 1. Okay, and again it is 1 1. So we'll get a sum of 0 and carry of 1. Okay, so sum of 0 and carry of 1. So and next one is 0 1. It is a 1. Okay, and
010100, sir.
Yeah. Okay, so 0 1 0 1 000. Okay, so this is two's complement. Just add 1 to the ones complement. Okay, add 1 to the ones complement will give you the two's complement. So which is very simple. So ones complement is just change ones to zeros and zeros to ones here. So that is ones complement and the two's complement. Okay, let's come into nines complement. So if I talk about decimal number system, so binary number system we had two complements here. So ones complement and two's complement. So coming to decimal number system, we'll have two complements here. So we have two complements, that is tens complement and nines complement. So or I can say that nines complement and the tens complement. Okay. So nines complement subtract each and every value that is given from 9. So if I say that find the nines complement of 1, 2, 3, 9, 8. Okay, so what I have to do here is to subtract each and every value that is 1, 2, 3, 9, 8 from 9. Okay, so all 9 నుంచి subtract చేయాలి. So what I'll get here is, so this is the value of the 9's complement. So 9 minus 8, I mean we are talking about decimal here. 9 minus 8 is 1, 9 minus 9 it is 0, 9 minus 3 it is 6, 9 minus 2 is 7, and 9 minus 1 it is 8. So 87601 is the 9's complement of 1, 2, 3, 9, 8. Okay, so this is 9's complement of 1, 2, 3, 9, 8. And if I want 10's complement of 1, 2, 3, 9, 8, just add 1 to the this one.
Screen is not visible, sir.
అందరికీనా 1 minute.
Yes, sir, not visible.
ఇప్పుడేనా ఫస్ట్ నుంచినా?
ఇప్పుడే
Okay. Now?
ఎస్ సార్
Okay. So decimal number system, we have two's complement here. So we have two complements with decimal number system. So that is 9's complement and the 10's complement. Okay. So 9's complement is subtraction of the given value from all 9's here. Okay. So here 1, 2, 3, 9, 8 is the given value here. So if I want to find the 9's complement of this 1, 2, 3, 9, 8, so subtract each and every digit from 9. Subtract each and every digit from 9 here. So 9999, we have 5 digits here. So I'm using this 5 nines here. So these values are subtracted from 9 here. So 9 minus 8, 1, and 9 minus 9, 0. So 9 minus 3, it is 6. 9 minus 2, it is 7. And 9 minus 1, it is 8. So 87601 is the 9's complement of 1, 2, 3, 9, 8. Okay. So 10's complement of 1, 2, 3, 9, 8 is 9's complement plus 1. Okay. Is 87601. Of is 87601 plus 1. What happened to this? Key is not working. 1 minute. One second. 87601 plus 1. Okay, so we'll get 87602. Okay, so 87602 is the 10th complement of 12398. Okay, just a simple concept here, but you have to apply this common sense here. Okay, so now what we have to find, so I'll say that to find the for a hexadecimal number system. I'm getting a problem with this. Next one is 10's hexadecimal, 15's complement and 16's complement. For hexadecimal number system. If I take hexadecimal number system, we have 15's complement and 16's complement. Okay, so in a similar way, so I have subtracted the given value of which we have to find the complement from 9 in case of the decimal number system and 1 in case of the binary number system. So what I'll do, I'll subtract the given values from 15 here. So if I want 15's complement of complement of 6 basic team AB7. So I want a 15th complement of this one, 15 and 16th complement of 56 AB7. So what I have to do? So I have to subtract each and every digit from 15. 15 is F. 15 is F. And subtract it from 56 AB7. So F is 15. Okay. So what are the values I get here? So 15 minus 7 is equal to 8. 15 minus 7 is 8. Okay. And if 15 minus B is 11. 15 minus 11 is 4. And 15 minus 10. So A is 10. So that is equal to 5. And 15 minus 6, that is equal to 9. And 15 minus 5, that is equal to 10, that is equal to A. So this is, so A9, 5, 4, 8 is the 15th complement of 56AB7. Okay, so 56AB7. So this is the 9th complement of this. Say this is the 15th complement of this one. If I want the 16th complement, so just add a 1 to this 16th complement. Is just add 1 to this. So add 1 to this. So add 1 to this value A9548. That is what I'll get here is A9549. Okay. So this is 16th complement of 56AB7. Okay. Are you getting my point?
Yes, sir.
Yes, sir.
Yeah. So this is how we have to do the complement. So if I want the 8th complement, or if I want the 10th complement, I mean 9th complement, or 3's complement, 2's complement. So what are the complements? We will be having two kinds of complements here. Okay. So R's complement and R minus 1 complement. Okay. So just adding 1 to the R minus 1 complement, we'll get the R's complement. Okay. So what is the necessity of using the complements? So generally, when we talk about the digital design, so in the future classes, you are going to design the circuits. Okay. You are going to design the circuits. So when we are designing the circuit, so what we'll think every time is like we have to minimize the number of circuits. I mean, minimize the number of components used in the circuit. Okay, we have to minimize the number of components used in the circuit. Or what we have to think about is here is like we have to minimize the cost of the circuit. Okay, cost of the total cost of the circuit. Or we have to speed up the system. Okay, so we'll think all these things here. So generally, when we come across the subtraction, actually subtraction is very costlier. Implementation of subtraction is very costlier when compared to implementation of addition. So addition is very easy. So implementation of addition is very easy. And actually, the implementation of subtraction is, I mean, most of the circuits will prefer the different method in implementation of the subtraction. Okay, so instead of using the subtraction method, so we'll use the complement method. Okay, we'll find the complements and we'll add these complements to the given value so that it will give the correct result. Okay, so generally what is the purpose of complements is, so it will substitute the purpose of subtraction in digital circuits. Okay, it will substitute the purpose of subtraction in digital circuits. Okay, so that is the main purpose of using the complements. So complements will make the subtraction easy. Okay, so we'll make the subtraction easy. I mean, so generally when I say that A minus B, So what I can say here is, so generally what I have to do here is, so a minus b. So the implementation, how to implement this a minus b. So instead of using the subtraction operation, what I'll take here is, so I'll take a plus, if it is like binary number, so 2's complement of b. So what I'm doing here is I'm finding the 2's complement of b and adding the 2's complement of b to a. So just we are performing the addition operation and adding the 2's complement of b to the a here. So the result will be in the correct form. So we'll know how the result will be. We'll be having three possibilities. So when a less than b or a greater than b or a equal to b, so we can get the two or three different results. So based on the results, we'll check what we can do with the result here. Okay. So generally, the complements are two types here: R's complement and R minus one complement. For a binary number system, we have ones complement and two's complement. For decimal number system, tens complement and nines complement. And for hexadecimal, 15's complement and the 16's complement. In the similar way for octal, 8 and 7's complement. Okay, so each complement is implemented. What I told you the technique earlier here. Okay, and coming to what is the purpose of complements here is, so complement will subtract the, I mean, we will substitute the need of subtraction. Okay, so instead of using the subtraction method, so what we'll do here is we'll go for the complement method. Okay, so if I say that if it is a minus b, so I'll take the 2's complement of a minus b. If I'm talking about this a and b are two binary numbers, and if I want to perform subtraction of two binary numbers, so what I can do here is, so take the 2's complement of the b here and add a to the, I mean add it to a here. So just we are doing the addition, and with the help of complements, additional complements will give the subtraction operation here. So how the subtraction is implemented here is with the help of addition plus the complementing operation will give the subtraction of, I mean will give, I mean which can substitute the subtraction operation. Okay, so addition plus complements will give substitute the subtraction operation. So that is the main purpose of using the complements. So and complements will reduce the cost of the circuit. Okay, it will reduce the complexity of the circuit. So it will, I mean, instead of using this subtractors, we can just go for the complementers, and we can use the adders. With adders and complementers, we can implement the subtraction operation. So we are reducing the number of circuits used here, because we have to use the adder, and if I want to use a subtractor, it will increase the total cost of the circuit. So what we can do here is just we can substitute that with a complementer, so which is economical and so which is feasible in terms of the digital design. So most of the digital design circuits, instead of implementing the subtraction operation, so they'll implement the complementing operation. Okay, they implement the complementing operation. So that is what I want to say regarding this complements here. Okay, so getting my point.
Yes, sir.
Yes, sir.
Right. Taking take down this problem. So find the ones and twos complement of the following. Find the ones and twos complement of the following binary numbers. So it may be easy, but just do it. So find the ones and twos complement of these numbers. Okay, so just a simple technique. You can just go with it. And then the next problem will be take the next problem. Find the 16th complement of this value. And the same thing. So B problem under this. So it is the second problem today. So 2A, B. So this is the hexadecimal number. So convert it into binary. This is totally a single problem. This is the second problem here. So first of all, find the 16th complement of BA. So subtract from, first of all, find the 15th complement and add 1 to the 15th complement. And afterwards, convert this BA into binary. It's hexadecimal to binary conversion. So each and every digit is given as 82414. So BA is given 82414 here. Okay, and convert the 2's complement. Find the 2's complement of the result in B. So we will find the binary value of BA. Okay, and convert that into 2's complement and get the 2's complement of that. Okay, and convert the result in C to hexadecimal values. So segregate with 4 binary values. Okay, so 8421 codes and compare with A here. So you can compare that result what we got in B with A. So tell me the answers. So 15th complement of where you subtract these values from 15. Okay, 15 minus B is 11.
4 5 4
4 5 4
4 5 5
4 5. So this is 15th complement. And if I want to find the 16th complement, is just add 1 to the 15th complement. Is equal to 4 5 4 5 plus 1. So that I will get it as 4 5 4 5. Right? This is the 16th complement. And we got A here. Convert BA to binary. So that is the second problem. So binary to hexadecimal conversion. hexadecimal to binary conversion. Okay, so how can we convert hexadecimal to binary? So what is 8421 codes of B, A, and B? So what is hexadecimal code of B? 848421 code. You forgot.
1011.
1011 is hexadecimal 8421 code of B here. So A is 1010, and here again 1011 and 1010. Okay. Now this is the binary code of this one, and what we are asked here. So convert this B is over. The problem B is over. Convert BA to binary, and the third problem is C. Find the 2's complement of the result in B. So we got this value here. I want to find the 2's complement. So first of all, find the 1's complement of this value here. I need to find the 2's complement of this one. So 1's complement of this one is 0 1 double 0
0
0 1
0
1
0
0 1 double 0 and
0
0 0 1. Okay, and 2's complement of this one is 2's complement of this one is, just add 1 to this. Okay, add 1 to this, you'll get the value. Okay, so add 1 and last one add really. So 1 1 is
05.
this is 1. Okay, so what I'll get here is, so 1 1 is 0, 1 of carry here. So 1 0 and then 1 0. So carrying this last one 1 add is same also 1 1 is 0 also, the carry of 1 also. So 0 1 1 0. Okay, last one is 0 1 1 0. And remaining things are same. 0 1 double 0 0 1 0 1 0 1 double 0. We got these values. This is the 2's complement of the BA here. Okay, so it is nothing but 4 5 4 6.
4 6.
Nothing but 4 5 4 6. If I take it as this one, this 4 5 4 6. Okay, and convert the result into hexadecimal. So this is the B value here. So hexadecimal compare this thing. So we get this into, this is the result of hexadecimal value of the previous value. Hexadecimal of C result. Okay, so we got this result. So hexadecimal result of result C result is so 4 5 4 6 here. Okay, so and compare with A, yes. So A we got the value of the same year. Okay, so A 16th complement of BA is 4 5 4 6, and here also we get as 4 5 4 6. So both are equal here. Okay, so hexadecimal equivalent of this one is equal here. So both the result A and D are equal here. So that is what we can conclude here. Right? This is the kind of problems you can expect, and we'll see the subtraction. So how to perform the subtraction using these complements here. Okay, so we'll perform some subtraction operation. So we'll see how the subtraction operation is performed using 1's 2's complement and 9's and 10's complement. Okay, so we'll have a method here for performing subtraction. So first of all, we'll see with the tens complement here. So subtraction using the complements. Okay, this is the topic we have to see. So we'll straight away go with example. Okay, so using tens complement. So take note this problem. Okay, so using tens complement, we have to perform this operation here. Okay, so normal subtraction అయితే ఏం చెప్తాము. So we'll just directly subtract from this one here, but we have to use a complement method here. Okay, so if I take this as a minus b, I have to find the tens complement of 3250 here and add this tens complement of 3250 to 52532. Okay, add the tens complement of this one to 52532. So first of all, what I have to do, we consider this as a is equal to okay and b is equal to this value. So when you lose the connection? So am I audible?
Yes, sir.
Yes, sir.
ఎంతసేపు అయింది కనెక్షన్ వెళ్ళిపోయి? So when you lost the connection,
5
just drop
minutes.
it. 5 minutes పడుకుందా? Just I'm keep on going. Like after few time, I just observe చేస్తే ఆడ ఏం లేదు, నేను చెప్పుకుంటూ పోతున్నా. So sometimes there'll be network issues, right? So this Google Meet has a problem of this one. So మిగతా ఏ ప్రాబ్లం రాదు కానీ Google Meet ప్రాబ్లం ఉంటుంది. Just let me know. So you have taken this problem. So subtraction using tens complement. ఈ ప్రాబ్లం తీసుకున్నారా? రెస్పాండ్. సో ప్రాబ్లం చేస్తున్నారా లేకుంటే ఎక్కడ స్టాప్ అయింది?
ఇంకా చెప్పలేదు సార్. స్టార్ట్
ఇది వచ్చిందా? స్టార్ట్ అయింది అంతేనా?
ఓవర్ సార్.
Okay. Yeah. So we'll see the method of subtraction using complements here. Okay. So subtraction using the complement. So using tens complement, subtract. So 52532 minus 3250. So we have to use the tens complement and perform the subtraction. Okay. So we have to perform the subtraction. So take the value of a as this one. So just for information here. So I'll take, if this is a here, 52532. And instead of taking 3250, so we'll take it as 03250 because we are having 5 digits in A. So we'll take the value of B as 03250. And we can conclude that A is greater than B here. So A is greater than B. Okay, so A is greater than B. When A is greater than B, the first step will be like this. So take the tens complement of the 03250 and add to this. So 52532. ఓకే, సో ఏం చేయాలంటే టెన్స్ కాంప్లిమెంట్ తీసుకొని, సో ఈ ఎండ్ ఏదైతే ఉంటుందో సో దీని టెన్స్ కాంప్లిమెంట్ తీసుకొని దీనికి యాడ్ చేయాలి. ఓకే, సో ఫస్ట్ ఆఫ్ ఆల్ స్టెప్ 1 ఇస్ టేక్ ద టెన్స్ కాంప్లిమెంట్ ఆఫ్ 03250. ఓకే, ఆర్ యు గెటింగ్? సో 03250 కి టెన్స్ కాంప్లిమెంట్ అంటే ఫస్ట్ ఆఫ్ ఆల్ నైన్స్ కాంప్లిమెంట్ కనుక్కొని దానికి 1 యాడ్ చేయాలి. సో నైన్స్ కాంప్లిమెంట్ ఇస్ నథింగ్ బట్ సబ్ట్రాక్టింగ్ ఆఫ్ ఈచ్ అండ్ ఎవ్రీ డిజిట్ విత్ 9 here. So all 9s minus 03250, so I'll get the value of 96749 and plus 1 will give you the 967. So this is not 976, 96750. Okay, so this is the tens complement of this value here, 03250. Okay, now what I have to do, coming to step 2, so add a tens complement of 03250, that is 96750 to 52532. ఓకే, సో 96750 కి సో మనం అడిషన్ చేయాలి ఇక్కడ. Okay, so we have to perform addition of 96750. So what is this 96750? It is nothing but it is a tens complement of 03250 is tens complement of 03250 is 96750. So this 96750 is added to 52532. Okay, so after addition, so what is the value I'll get here? 149,282. Okay, so 14928. Okay, so 149,282 here. Okay, so you can see here, so we are adding two 5-digit numbers, but we are getting 6-digit number here. So the last digit is called as carry here. Okay, so last digit is called as the carry. So what we have to do here is when A is greater than B, so we have to discard this carry. We have to discard this carry. So discard and the result is like 49282. So that is the result we'll get here. You're getting my point? So this is the value I got here. Okay, so when A greater than B, Okay, so when A greater than B, so we get an end carry. We'll get an end carry, so which should be discarded, which is discarded. So discarded in the sense, so we'll ignore that. We'll not consider it for the result. Okay, so here, so after discarding this 1 year, so the value I'll get here is, the final result is like 49282 is the result here. Okay, so when A is greater than B, so I'm taking this value of A here, and I'm telling the procedure one more time here. So this is the value of B. So since the value of A is like 5 digits, we'll also take the value of B as 5 digits by by adding zeros here, sufficient zeros to the left. A is greater than B. So when A is greater than B, if I perform the subtraction using the any complement, so I'll get the carry. I'll get the n carry. So this n carry should be discarded here. Okay. So and after discarding the n carry, so the result we got is nothing but the final result here. Right? Clear?
Yes, sir.
Yes, sir. Yes,
So
sir.
when A is greater than B, if I perform subtraction, I'll get the positive result, and I will get an n carry here. So that n carry should be discarded here. Clear?
Yes, sir.
Okay. So this is the method here. So using tens complement అయితే ఇలా చేయాలి. Subtraction, if I want to perform subtraction with tens complement, okay. First of all, take the tens complement of this end. So this is called as minuend. This is called as subtrahend. Okay, I want to say this. This is and this is subtrahend. Okay. This is the spelling. So this minuend and this is subtrahend. So take the tens complement of the subtrahend here. Okay, so this is having 5 digits, and this also we have to make it as 5 digits by adding sufficient number of zeros here. And first of all, we have to check the case here. A is greater than B. When A is greater than B, and if you don't understand also A is greater than B na less than B na artham kaakapoyina kuda, so if the result we get an n carry of 1. Okay, so when I'm performing, just find the tens complement of this value here and add this tens complement to this 52532. So what I get here, so 149282 here. So this is the result I got here. Okay, so this we got 1 digit additional here. So this is because we are adding 5 digits and we got the result of 6 digits here. And the last 6 digits is called as a carry here, n carry. Okay, so that n carry, if I get this n carry, I can say that A is greater than B. A is greater than or equal to B. A is greater than or is equal to B. Okay, so when A is greater than or is equal to B, so I can say that. So we'll get an n carry, and that n carry is discarded, and this is the remaining result here. Okay, and I can say that A is greater than B here, greater than or equal to B here. And if I'll take one more example of A is less than B here. Okay, so when A is less than B, definitely I'll get the result in negative here. I'll get the result in negative, and the result should be represented in the with the negative value of the 2's complement. Okay, so second method is, so this is the case for A is greater than B. Okay, this is the case for A is greater than B here. Okay, and on coming to the next one, we'll see the case where A is less than B. A is less than B. So you take this problem using using tens complement, subtract 3250 minus 72532. Okay, so this is minuend and this is the subtrahend. So always take the tens complement of the subtrahend here. Okay, so here A is less than B, so you can find this. So step 1 is take the tens complement of 72532. So tens complement of 72532 is subtract from all lines here plus 1. Minus 72532 plus 1. Okay. So 9 minus 7, it is 2, 7, 4, 6, 7. But plus 1 is, we will get it as 6, 8. 2, 4, 7. Sorry, 2, 7, 4, 6, 8. So this is the tens complement of 7, 2, 3, 5, 2. Okay. Now I want to find this 3250 minus this value. So this value, I'll get this value. This replaced with this tens complement of 72352. Okay. So 3250. So here we get 5 values in the out. I'll add 0 to this. Okay. And add this 27468. 27468. So add these values. Okay. So the values I get is 30718. Okay. So in the mundu in the case so we got a carry here. So when we get a carry, additional carry, extra carry, so we can say that so A is greater than B. We say that A is greater than B. We'll discard that n carry, and that value will be the result. So in this case, we don't get n carry here. We are adding 5 values here. We are getting the 5 values as a result here. Okay. But this is not the correct result here. There is no n carry. Okay. And this is not the correct result. So what we have to represent here is, so we have to again take the tens complement of this value and give a negative sign to this value here, tens complement of this value. Okay. So here what I can conclude here is there is no n carry. Okay. And so when there is no n carry, A is less than B, we can conclude that A is less than B here. Okay. So when A is less than B, when A is less than B, okay, so take tens complement of the result. So whatever result we get here, so take tens complement of result and assign negative sign. So to indicate that the result what we get here is negative value. Okay, so here 30718. So what I have to do? So I have to take the tens complement of this 30718 and assign the negative value. Tens complement of 30718. Okay, so 3 is a tens complement and subtract from all lines plus add 1 to this. Okay, so 9 minus 1, 2, 3, 4, 5 minus 30718 plus 1. Negative sign will be there here. Okay. So what is the value I'll get here? So minus 69282. This is the result here. Okay. So when A is less than B, so this is the case here. We don't get n carry here. The procedure is same here. So take the tens complement of the subtrahend and add to this menu n here. Okay. Add to this menu n. And if there is an n carry, discard that n carry. I can say that A is greater than B, discard the n carry, and the result is the final result here. And if I don't get n carry when I perform this tens complement subtraction here, so then I can say that the result is in negative form. The result, whatever the result I got here is should be in the negative form, and we have to take the tens complement of the result and assign negative value to the result here. Okay, so tens complement of 30718 and assign the negative sign to this one here. Okay, so clear?
Yes, sir.
Yes, sir.
Yes, sir.
This is using for tens complement on the nines complement. So tens complement. So this is for tens complement here. Okay. Now we'll see the twos complement subtraction here. Okay. So we'll see obviously we'll perform the twos complement subtraction. The same methods, but see there it will be the twos complement here. So take down the problem here. So given the two binary numbers, x is equal to 1010100 and so y is equal to so perform these operations. The first operation is x minus y and perform y minus x using two's complement method. So we had to use a two's complement method here. Okay, so remember this, we have two values here, x minus 1, we have to perform x and y here, so x minus y and y minus x. Okay, so if I get the n carry in case of x minus y, I can say that x is greater than y. Okay, and there is no need of assigning any negative sign. So I'll discard that n carry. Okay, I'll discard that n carry and the result will be the remaining values there. Okay, if I perform y minus x and if y is less than x, I'll not get the n carry. So what I have to do, I have to again take the two's complement of the result and assign negative value to this. Okay, so that is what we'll do here. So first one is x minus y. This is x here. Okay, and y what we have to do, we have to take the two's complement of y here. So if I want to perform x minus y, okay, so take using two's complement method, take two's complement of y. Okay, so two's complement of this one is equal to, that is, what is one's complement of this one? 0 1 1 1 0 0. So this is one's complement, and adding 1 to this, I'll get 0 1 1 0 1. So this is the two's complement. Okay, we have additional values 9 4 5 6 7 1 2 3 4 5 6. Yeah, and one other 0 here. Okay. Okay, so this is two's complement of y here. So take the one's complement of y and add 1 to this one's complement here. Okay, so generally this is the one's complement plus 1. So that will get as 0 1 1 1 1 0 1. So this is the two's complement of this value here. So add this two's complement to this x here. Okay, so x value is this one and add a two's complement to this. Just a plus symbol indicate that we are performing the addition operation using the complements. Right. So taking the two's complement, we will start from the last here. Zero one, it is a 1. Okay, and 0 0, it's a 0. 1 1, it's a 0 and carry of 1 here. We'll get a carry of 1. Okay, so I don't have this notations. So చూడండి just general గా. Okay, so 0 and 1, it's a 1, 0, 0, it's a 0. So 1, 1, it's a 0 and carry of 1. We'll get a carry of 1 here. So again 1, 1, it's a 0. Okay. So because we got carry from the earlier one, so 1, 1 is 0 and carry is 1 here. So again we got a 1, 1 here. So 1, 1 is a 0 and carry of 1 here. Okay. So here we get a carry here. So we'll get a 1, 1 here. So 1, 1, 1. So when it is 1, 1, 1, the sum is also 0 and carry is equal to 1 here. Okay. So 1, 1 aithe 0, 1. Sum is 0, carry is 1. Adi 1, 1, 1 aithe, so sum is 1 and carry is 1. So here it is a 1. Okay, and carry is also equal to 1 here. So here we get a carry of 1 here in this place. So again it is 1, 1, it is equal to 0, sorry, 0 and carry of 1 here. So again it is, so 1, 1, it is 0 and we get a carry of 1. Okay, so totally this is the values we'll get here. So we have 1, 2, 3, 4, 5, 6, 7 values. So 1, 2, 3, 4, 5, 6, 7, and we got an n carry here. So that n carry is discarded here. Okay, so I got an n carry. That n carry is discarded. So this is the sum. So we have to discard the n carry. So because of here, I can conclude that x is greater than y because we got n carry. Okay, so hence discard n. So that is equal to n carry. So discard n carry. What I mean to say here is discard n carry. So the result is so 0, 0, 1, 0, 0, 0, 1. Okay, so this is the value of the x minus y here using 2's complement method. Getting my point?
Yes, sir.
Everyone getting the points, like it's okay. That yeah. Right. So if you have any mistakes, you can correct them. Right. And coming to the next one, y minus x. Perform y minus x. So this is x minus y. Perform y minus x. The value of y is this one. The value of x is initially this one. The want perform y minus x. If I get an n carry, so the meaning of this is x is, I mean, y is greater than x. If I don't get n carry, I'll say that y is less than x. Okay, then I have to take the 2's complement of the result what we got and give the negative sign for this. Okay, this is y here, and this is x. So first of all, so perform take the 2's complement of y because so y x is on subtrahend here. So perform 2's complement of the x here. 2's complement of x, that is equal to 0, 1, 0, 1, 0, 1, 1 plus 1. 1 complement plus 1. So last లో ఏమొస్తుంది మనకి ఇక్కడ? So here 1, 1, and 1's complement. Whose complement is like 0 and So 1 is forwarded to the next location here. So 1 1. So we'll get a 0 1. Okay, and the remaining things are same. So 0 1 0 1. Okay, so this is the 0 1 0 1 1 0 is the 2's complement of x here. So add this 2's complement of x to y. So add the 2's complement of x to y. So this is y here. Okay, and this is the x what we got here. Missed something. So 1 minute. Okay, so this value is 2's complement of x here. Okay, add this 2's complement of x to this value here. So the result I'll get here is it's 1 1 0 1 1 0 1. So here 1 1 0 1, and here it is a 0, and it is a 1, and here it is a 1. Okay, so these are values I'll get. And I add these two values. Okay, that is so 1 1 0 1 1 1 1. Okay, so here I'm not getting n carry because these values are 1 2 3 4 5 6 7, and result is also of 7 bits here. So 1 2 3 4 5 6 7. Okay, so there is no n carry. So what I can conclude here is there is no n carry. So y is less than x. So take 2's complement of result and assign negative sign. Okay. What is the result here? This one. So negative sign and 2's complement of this one. Okay. So 2's complement of this one is negative of, let's take the 1's complement, 0 0 1. Okay, and add 1 to this, plus 1. I'll get minus of 0 0 1 0 0 0 1. Okay, so this is the result of this one here. So clear?
Yes, sir.
Yes, sir.
Everyone. So what are the method you get here is, so one is getting the n carry, other one is not getting the n carry. So when we don't get that n carry, so what we have to do here is, so we have to take the subsequent complement there, and we have to give the negative sign for that. Okay. If I perform these operations using 1's complement method, ante ikkada kuda same n carry vaste AMJM or n carry discard JCC will just give the result. If I don't get the n carry, so I said that we have to perform this operation using ones complement. So what we have to do? So just we have to take the ones complement of result here. So instead of and give the negative sign. Instead of two's complement, I'll be giving the ones complement. Okay. So take note another problem. So that is using the ones complement. So do the same problem. So do the same problem. So with the ones complement to perform the same operations with ones complement. So take note this problem. So use the ones complement only. So, but there is a small change here. So in case of diminished radix complement, okay, so in case of diminished radix complement, so this is the radix complement here using subtraction. So whatever the n carry we get, we discarded it. You can see here. So we discarded the n carry. But in case of this r minus 1 complement, r minus, so take the note of this, r minus 1's complement. So r minus 1's complement ante it is 1's complement annavachchu, 9's complement avachchu, lekunte 15's complement avachchu, whatever the complements. Okay, so the n carry, okay, n carry what we get is result. Okay, so ikkadaithe discard chesamu. So in case of this one, so discarded the n carry in case of the r's complement. Okay, so I want to conclude this. In case of r's complement, the n carry is discarded. Okay, but in case of r minus 1's complement, then carry what we get is added to the. So what we can do here is just I'll tell the example of this. Okay, so x minus y, this is the value of x. Okay, and take the y is for y. What we have to do, we have to take the 1's complement of y. One's complement, because we have to perform this operation using 1's complement. One's complement of y. Let's change ones to zeros and zeros to ones. So that is 0, 1, 1, 1, 1, 0, 0. Okay, and we have to perform the addition operation here. Perform the addition operation. Okay, so what we'll get here, so 0, 0, 0, 0, 0, 0, 1, 1 is 0, 1, and again it is 0, 1, and it is 1, 1. So just perform these operations. So the values I get here is 1, 0, 0, 1. Okay, so any changes, any corrections to the take this quantity. So n carries 1 here. Okay, so I got an n carry of 1 here. Okay. So in case of 2's complement subtraction అయితే ఇది discard చేయాలి, but in case of 1's complement అయితే what we have to do, so add this 1 here to this one. The carry is discarded. I mean, it's not discarded, just add to this value here. Okay. So result I'll get here is 0 0 1 0 0 0 1. Sorry, go 0 yeah. 0 0 1 triple 0 triple 0 4 0. Yeah. Okay. So there's a way we have to deal with the r minus 1's complement. So if it is like 9's complement also, n carry oste add cheyali. If it is like if I say that 7's complement also, I have to add this n carry to this one here. Okay. So there is no such rules in case of this method. So y minus x, if y is greater than x aite, y is less than x aite, just instead of using the 2's complement, just I'll be using the 1's complement. Okay, I'll perform y minus x. So take the 1's complement of this one here, x here. Okay, and take the result in the form here. So we can do here. So y minus x, the value of y is this one here. Okay. And x is this one. And to take the 1's complement of x here. One's com of x one's complement of x is 0 1 0 1 0 1 1. 0 1 0 1 0 1 1, and the result I'll get here is 1 1 0 1 1 0. So this is what I'll get here if I perform this operation here, because it is 1 1, it is 0 1, and it is 1 1 1, it is 1 1 carry of 1. Okay, and here it is also equal to 1, and 0 0 it is 0, 0 1 it is 1, and 1 0 it is 1. So there is no n carry here. So when there is no n carry, I have to take the result so in negative form and 1's complement of result here. Complement of this one. So what the result I got here. Okay. So that is equal to minus of 1's complement of result is 0 0 1 0 0 0 1. Okay, so that is in negative sign. Okay, so this is how we have to deal with the 1's complement. So the one condition is, so when we get the n carry, just add that n carry to the result. So in case if like x is greater than y. Right, clear?
Yes, sir.
Yes, sir.
Yes, sir.
So don't simply say yes.
Yeah.
No, I'm just telling in a slow phase here. Okay, so take down the problems, assignment problems. So we'll know, right? So we'll see the assignment problems. So there is a method here. So I have to follow this method. Okay. So we'll see a few problems on subtraction. Okay, and we'll discuss those problems. If you have any doubts, we'll discuss those problems tomorrow. Okay, so wait a minute, 1 minute, give me 1 minute. So I'll be giving the assignment problems. Just wait for a minute. Yeah, so we'll take decimal problems. So solve those problems because subtraction may be a little bit confusion. So we'll solve more and more problems. So take down the first one. So perform the following arithmetic using two's complement method. The first one is right. This is the first problem. So first problem one and second. So perform the following arithmetic. I mean, we have to perform subtraction using two's complement method. And take the problems like this only. కొన్ని చేయండి మీకు అర్థమవుతుంది. So one. Right, this is one kind of problems using two's complement. Next, perform subtraction using tens complement. One zero two zero minus 2056, and the second one is 0 minus 1308. So this is using tens complement. So this is using tens complement. Do that using tens complement. And so one more problem. So perform following operations using two's complement. This is one different problem in ikkada. So using two's complement cheyali. Okay, but what the values I get here, I'm giving here is decimal values. 21 minus 42, and second one is 46 minus 25. Okay, so I given the decimal value, so but I want to perform this operations using two's complement anan. So two's complement ante first of all find the binary values of 21, 42. Okay, and find the two's complement of 42 here, and add this two's complement of 42 with 21. Okay, so don't perform this tens complement gaani nines complement gaani. So first దీన్ని binary లో convert చేసుకొని చేయండి. Okay, so there is a hint for this. So convert them to binary. Okay, and afterwards do the operations. Right. So this is it. This is about the complements and the subtraction using the complements. Okay, all those numbers we discussed here is unsigned numbers. So I'll let you know the difference tomorrow. Unsigned numbers, signed numbers, 7 untayi. So we'll let you know about these unsigned numbers, and what are the numbers we discussed here is unsigned numbers. So unsigned ante, so we are not giving any value to this sign here. Okay, so actually positive అయితే ఒక సైన్ ఇస్తాము, నెగిటివ్ అయితే ఇంకో సైన్ ఇస్తాము. లైక్ పాజిటివ్ అయితే 0 అని, నెగిటివ్ అయితే 1 తో రిప్రజెంట్ చేస్తాము. బట్ we are not considering the signs here. We are talking about the unsigned numbers here. Okay, so these are the unsigned numbers. So what we discussed today is the unsigned numbers. Okay, so clear?
Yes, sir.
Yes, sir.
Okay, if you have any doubts you can ask. After ready unnara attend cheskoni fast unnaru meer. Fine. So anyway, so no problem. You are taking these problems, right? So don't refer the recordings. Recordings mari నేను బెట్టకి లేట్ అవుతుంది, ఈ రోజు కానీ రేపు కానీ పెడతాను. బట్ అంత లోపల మీరు చేసేసేయండి. Okay, so you'll definitely get this soft copies of this digital design textbook by Maurice Meno. Okay, so నెట్ లో కొట్టేస్తే వచ్చేస్తుంది మీకు. 4th edition కానీ 5th edition కానీ వచ్చేస్తుంది. Okay, right. So we'll see you tomorrow. Tomorrow I'll let you know the timings. So maybe morning or in the evening. Okay, I'm not sure. So whether what time I'm taking. So if I'm busy in the morning, I'll be taking classes in the afternoon. Yeah. So we are not sure when your college starts, but please make sure that you'll be in learning mode. Okay. ఎందుకంటే ఇంకొక కొద్ది రోజులు పోతే ఇంకొక సంవత్సరం అయిపోతుంది. ఇంకొక డిసెంబర్ వచ్చి మార్చ్ వచ్చింది అనుకోండి, ఒక సంవత్సరం అయిపోతుంది మీ కాలేజ్ రాకుండా. ఓకే, సో మోటివేషన్ మనకు కావాలి. మోటివేషన్ లేకపోతే ఎట్లయిపోతుందంటే విల్ బి బ్యాక్వర్డ్. సో యాటిట్యూడ్ విల్ బి చేంజ్. ఇప్పటికే చాలా చేంజ్ అయింటుంది, బట్ ట్రై టు మేక్ షూర్ దట్ యూఆర్ ఇన్వాల్వ్డ్ ఇన్ యువర్ కరికులం. ఓకే, so many people are attending the classes for formality, and that means even use taru. Okay, but don't be like that. Just చాలా కష్టం అంటే ఆన్లైన్ మోడ్ లో ఉంటూ మనం డైవర్షన్స్ చాలా ఉంటాయి. It's very difficult for you to concentrate, but no option, right?